Alright, welcome to section 1-4, solving absolute value equations. Let's get started today. First, let's take a look at our objectives for this section. First of all, we want to evaluate expressions involving absolute values. Remember again, an expression is something without an equation or an equal sign in it. And secondly, we want to solve absolute value equations. So this one will have an equal sign in it. Alright, so first of all, what is absolute value? You may know a few of these things, but let's take a look. First of all, absolute value is the distance of a number from zero. It doesn't matter what direction it is. If something is 5 units away from 0 in the positive direction, that would be at the number 5 on the number line, it has an absolute value of 5. If it's at -5, that is also 5 units away, so its absolute value is also 5. It'd be like, you know, if I was talking to one of you, and let's say I lived 10 miles from the school to the east, and you live 10 miles from the school to the west, and somebody asked us how far we lived from the school, we would both say, oh, I live 10 miles away from the school. We live in different directions, but we would both say that we live 10 miles away. Okay, so that's absolute value. Absolute value is represented by the symbol where you have those straight up and down lines. And so in this case, that is what represents the absolute value. That's how you know when to do the absolute value. And the absolute value is always positive. And of course, sometimes it could be 0 as well, but mostly positive. So here's a few examples. Let's take a look. First of all, this is read as the absolute value of 8. Well, what's the absolute value of 8? It's just 8. Okay, so it just took whatever's inside the bars there and made it positive. And then also now we have -4 here, so we say, well, what's the absolute value of -4? It just takes whatever's inside there, makes it positive, and so that would be a +4. So no matter what is inside those absolute value bars, it just takes it and makes it positive. Okay, so another example I use is it's like a car wash. Absolute values are like a car wash. If a car goes in clean or positive, it's going to come out clean. It didn't really change anything. But if a car's dirty and it goes in, then it's going to come out clean. Okay, so both ways it's going to come out clean, which means it's going to come out positive. Okay, I don't know if that helps, but I heard that one time. All right, first of all, evaluate an expression. All right, here's our expression. 8.4 minus the absolute value of 2n plus 5, and n is -7.5. All right, so let's start out here. We've got our 8.4. Minus absolute value, I'll deal with that in a second, 2 times n. Well, we know that n is -7.5, and then plus 5. Okay, so first step is plug it in. Now the other thing about these absolute value bars is they act like grouping symbols. So they act like parentheses, in the sense that when you're doing please excuse my dear Aunt Sally, you do those first. You do what's in the absolute value bars first, and then you take care of the rest of it. So in the absolute value bars here, we're going to follow please excuse my dear Aunt Sally. What do we do first? Well, we've got some multiplication and we've got some addition. So we're going to do the multiplication first here, right? So this stuff out here didn't change. We still have 8.4. And that now we have 2 times the -7.5 will be -15. Now we do the addition inside the bars there. So that's going to give me the absolute value of -10. We still have the 8.4 and the subtraction out front here. Now we take the absolute value of -10, which would be +10. So I have 8.4 minus a +10. Notice when we took the absolute value, it got rid of this negative right here, but it did not affect this one out here. So this negative out here, that is still here, okay? So it didn't turn that into a plus. That stayed negative, the one that was outside. It only affected the one that was inside. And then the last thing we can do there is actually subtract those, and so we'll have equals a negative 1.6. Okay, so all we did was plug it in, work it out still according to the please excuse my dear Aunt Sally, but we do, whenever we get that down to a number there, we will take the absolute value of that in that situation. All right, let's take a look at solving absolute value equations. Okay, here's some of the rules for this. All right, first of all, if you are going to solve an absolute value equation, first thing you need to do is isolate the absolute value expression. So if there's anything attached outside of that absolute value, and I'll give you a few examples in a second here, if something is being added to it or it's being multiplied by something, we need to clear that away first. Okay, that's the first step. Secondly, you're going to take that equation and write it as two separate equations, and I will explain that in a minute as well, why that's the case. Then we'll solve the two equations. We could get two possible answers here. And the last step there is you always need to check your solutions on this one, because there are times where you could have an extraneous solution, something that looks like it's a solution when you solve it, but when you actually plug it back in, it doesn't work. Okay, so you do always want to check your solutions on these. All right, so let's take a look at a simple absolute value equation here. This is pretty easy. If you look at this one, you'll notice, first of all, that here there's nothing attached to that absolute value bars. Okay, so remember what I said in the first step up here? I said isolate the absolute value expression. Well, it's already by itself. There's nothing multiplying times the absolute value bars, nothing being added, nothing subtracted. So it's already by itself. So now I'm going to write it as two separate equations. Now here's why I have to do that. Think back to what absolute value means. Okay, let me give you an example here. Let's say we have the absolute value of x equals 3. Okay, I'm kind of doing the same thing I did over here, except instead of x plus 8, I'm just making it x. Well, if I take the absolute value of x, and if I'm going to get 3, what are my possible numbers for x? X could be 3, or it could be negative 3, right? If I plugged in 3 in for x, would it give me an answer of 3? What if I plugged in negative 3 for x? Would that also give me an absolute value of 3? Yes. So here's what happens is, because absolute value, it doesn't matter what direction, negative or positive, that's why you've got two parts there. Okay. You may have heard me say this before, but if you've watched the movie Star Wars, I like to think of it as the Force in Star Wars. There's the good side, and there's the dark side. Okay, there's the positive side, there's the negative side. So whenever you see absolute value, if you've watched Star Wars before, you know anything about it, think of the Force. Okay, Darth Vader, Luke Skywalker. Then that's what you're going to pay attention to. You've got to split those up into the good side and the dark side of the Force. So, all right, so let's look at this here. On this one, x plus 8 equals 3. Based on what I did over here, what could x plus 8 equal? Well, x plus 8 could equal 3. That means if I plugged in 3 here, the absolute value of 3 would be 3. So that means x plus 8 could equal 3. But also, could I not also plug in maybe a negative 3 here for x plus 8? And if I did that, x plus 8 would have to equal a negative 3. So either way, 3 or negative 3, I will get the answer of positive 3 after I take the absolute value. So that means x plus 8 has to equal 3, or it has to equal negative 3. So if you can just remember, just take whatever's inside the absolute value bars, write one equation where it equals positive, and then one where it equals negative. Okay? That's when you start with a positive number out here. I'll explain that in a few minutes. Now we just solve them. Minus 8. Remember, do it to both sides. So x equals a negative 5 is one of our potential solutions, and minus 8, x equals a negative, x equals a negative 11. So those are our two possible solutions. And again, we want to check these sometimes if it's simple enough, you can just kind of do it in your head. But if we take -5 and I plug it back in here for x, -5, here, I'll do it over here, -5 plus 8, does that equal 3? Yep, that was a solution. What about -11? -11 plus 8, does that equal, well, does that equal 3 after we've taken the absolute value? I should have mentioned that before. When you take the absolute value of these. So -5 plus 8 is 3, absolute value is 3, -8 plus, or -11 plus 8 is -3, then we take the absolute value, it becomes +3. So don't forget to put the, when you're checking that the absolute value bars there do make a difference. So both of those check out. All right, let's move on. Absolute value equations. Let's look at a couple other ones. Now there's a few things attached to the absolute value. Notice up here on the top one, I have the absolute value of y plus 4 minus 3. The absolute value expression is not by itself. It has the -3. So what I have to do is I have to take whatever's been attached to it and move it to the other side. So I'm going to do +3. Those will cancel. So I have the absolute value of y plus 4 equals 3. Okay, now I've got the absolute value bar, the expression part there, by itself. And now I say, okay, absolute values, Star Wars. That means, again, remember what can go inside here in the side the bars in place of y plus 4 could be a 3 or a -3. So I'm going to write my two equations here. Y plus 4 could equal 3, or y plus 4 could equal -3. And I just solved both of those, -4. So it looks like I have that y could equal a -1, or -4 minus 4, y could equal -7. It looks like those are our two possible solutions. When you go to check this, if you want to, you could go back to this original problem, or assuming you've done this step right here to get the absolute value by itself, you could plug it into this equation as well. Both of those would work. So I'll just plug it in this one here. I'm pretty sure I did this right. So let's say we've got -1 plus 4. The absolute value of that, would it equal 3? That'd be 4 minus 1 is 3. Yep, that works. And then if I take the -7 here, I have absolute value of -7 plus 4. And -7 plus 4 is a -3. Take the absolute value, it makes it a +3, so that checks out as well. So both of those answers are good, and we would include both of those in our answer. All right, so far okay? Next one, we've got a similar situation here. This 8 is being attached. This time it's being added. So what do I need to do? Subtract 8. So now I have the absolute value of 3x minus 2 equals -7. Okay, what do you think you're going to do now? You thinking of Star Wars? Okay, that's good that you're thinking of Star Wars, but there's one thing to watch out for. When you get to this point, you notice you've got absolute value equals a -7. The key here is we have a -7. Before, when we had the absolute value equal to a number, it was always positive, and we just took 3. You know, when we set up the two equations, we did 3 and -3. Great. Okay, when it starts out with a negative, you cannot just say -7 and +7. A lot of people are tempted to do that. Why can I not do that? Well, what does absolute value mean here again? Absolute value means it has to be positive. So what you're saying, it doesn't matter what's inside the absolute value, is 3x minus 2, or, you know, x plus 7, or x, no matter what it is, whatever's inside this absolute value has to always be positive. It can never equal a -7. So you know what that means? Empty set. There's no solution. So you could just write, you know, that 0 through the line through it there. It means an empty set. Or you could write out no solution if you wanted to do that as well. So watch out for that when you're solving these. If you get to that point where the absolute value is by itself and it equals a negative number, there is no solution. Okay, no solution. All right, a couple more examples and we'll be done. Look at this one on the top. the absolute value expression is being multiplied by 3. How do we undo the multiplying by 3? Divide by 3. So we'll just divide the whole thing by 3. 3's cancel, so now I have absolute value of x minus 5 equals 4. Oops, sorry. That should be a bar there. And then it's positive. 4 is positive, so we're looking good. So that means I can split this up into x minus 5 equals 4, x minus 5 equals negative 4, and solve those by doing plus 5 means I've got one possible answer of x equals 9, and then plus 5, x equals 1 it looks like. So these looks like our two possible answers. Again, we want to check those. So if I plug it back in, again, you could go back to the original problem there, but I'm going to go to this one right here. So if I plug 9 in for x, I have absolute value of 9 minus 5. 9 minus 5 is 4. Absolute value is 4. Yep. And then I could plug in 1, so this means absolute value of 1 minus 5. That's a negative 4, but when we take the absolute value, it will equal 4. So it looks like they both check out. Okay, but in that one, you notice we had to divide by 3 to get it to a point where we could solve it. Last one, we got x's on both sides here. Oh boy, okay. But it doesn't really matter too much, but notice, is the absolute value expression, is it by itself? Yeah, it's by itself. Everything else is on the other side. So we can go through this the same way. There's one little thing we got to kind of watch out for that's a little tricky. But what did I do before? If I had the absolute value bars, I'd split it up into its two parts, right? So I'm going to do the same thing. Here's where it's a little tricky. I've got the x plus 10. Well, actually, it's tricky on the next step. 4x minus 8. And the next step would be that x plus 10 would equal, normally we just had a number over there, and we just did like here, you know, we just did 4. When we had 4, we did 4 and negative 4. Now we've got this whole 4x minus 8. What you have to do is make the whole thing negative. So 4x minus 8, put the negative in put in front of the parentheses around that term there. And what that means is you're going to have to distribute this negative. That's the tricky part. So you have x plus 10 equals negative 4x plus 8, because a negative times a negative is a positive. Here. So that's the little tricky part when you see an equation like this. But now from here, we just solve these two parts. And so here I'm going to go, let's see, I think I'm going to go this way. Negative x minus x minus x. Those cancel. So it's going to give me 3x here. And then I'll go plus 8. Plus 8, so that'll give me 18. And then I'll divide by 3. It looks like I have one potential answer of x equals 6. And on the other side, this time I'm going to go plus 4x. I'm doing this so I can avoid dealing with negative numbers in front of the x's. So this will give me 5x. Then I'm going to go minus 10. And it looks like I have a negative 2. Divide by 5. And that's okay. I mean, it looks scary because of the fraction there. That just means one of your possible answers there is x equals a negative 2/5. We do have to check these. Okay, so we do want to go back and check these. And again, this is this is why we're ending with this one. This is probably one of the trickier ones. But let's go back here. Let's do 6 first. I'm going to put 6 in here. So I have 6 plus 10. That's an absolute value, so let's see, I'm going to jump over to here. I'm kind of running out of room. So that's going to give me 16 on the left. And then here for this x, I'm also going to plug in 6. So this is 4 times 6 minus 8. So that's 24 minus 8, which is 16. So 16 equals 16. That one's good. Now it's kind of a hassle here with the fraction, but we do want to check this. You could possibly, since this 2/5 works out pretty evenly here, that would be a negative 0.4. So if you wanted to check it as a decimal, you could do that. And so our last thing here, we'll plug in 0.4. I'm going to just do negative 0.4 there for the x. So I'm going to have absolute value of negative 0.4 plus 10. And then equals 4 times negative 0.4 minus 8. Kind of running out of room, but I'm doing what I can here. And so when we do the negative 0.4 plus 10, that's the same thing as 10 minus 0.4, which is going to give me 9.6. And then on the other side, I've got 4 times the negative 0.4, which is a negative 1.6 minus 8. And you know what that gives me? Negative, whoops. Okay, that wasn't supposed to happen. There we go. Then that gives me a negative 9.6. So in this case, when we check these, look what we got here. 9.6 equals a negative 9.6. These are not an absolute value anymore. These are regular numbers, and so a negative and a positive number are different numbers. This one does not check out, so that means in our final answer we cannot use that negative 2/5. Our only answer is that x equals 6. Okay? Well, that's it for this time. That's solving absolute value equations. I'll see you next time in section 1.5. Thanks.